For today's class, our topic is about what is the plane wave is in the meaning as its meaning in quantum mechanics. So before we are going directly to what is the plane wave is, we have to relate this topic with the previous Schrödinger equations, independent and time independent Schrödinger equation works. So we have also mentioned several times about something called the free particle or free electron, that the particle is not affected or not subjected to any external forces. That means all forces equal to zero. There is no change in its energy and potential energy. There is no change in wavelength and momentum. So we can arbitrarily assuming their potential energy equal to zero for this free particle. So starting from the time-independent Schrödinger equation, we can start to describe the free particle electron motion. From this equation, this is the energy of the particle, the free electron particle, and this is the wave function which is describing the motion and behavior of this particle. This is the internal energy, and this is the Planck constant divided by 2 pi divided by the mass multiplied by 2, which is the second derivative of the psi of x, the wave function, with respect to the position. So if we are assuming the potential energy arbitrarily equal to 0, if it's assumed to be 0, then this is particle used to be named as free particle, and it's due that there is no external forces applied on this particle, and as a result the energy of the system keep to be fixed. So here the internal energy equal to 0, so this is the term will be deleted and equal to 0, just rearranging these couples of equation and just bring this one to the other side and moving to the 0 to the left hand side. So this is how it looks like, the Schrödinger equation for the free particle Schrödinger equation. If you have some background on the classical mechanics, this equation, Schrödinger equation for the free particle, its analogy or similarly looks like the equation of motion for single harmonic oscillation. And in similar way, it will have a solution. Its solution subjected to also the solution for the Schrödinger equation for free particle, and this solution is the sinusoidal solution. If we are subjecting or substituting the wave function in this equation into this Schrödinger equation, the result would be 0. So that's mean the solution of this Schrödinger equation. But there is another thing that we have to mention in this classical and quantum mechanics. K here is different than K it was mentioned in the equation of motion for single harmonic equation. In that equation of motion, classical equation of motion, K it was meaning the spring constant or the constant of the spring, which is Newton per meter, while the K in this equation is different thing. I will finally define the meaning and the value of this K in this equation. It cannot be described in the same manner with the classical mechanics. So this is the sinusoidal, can be describing the electron motion, the free electron motion in the Schrödinger equation. From the conservation equation, the energy of any particle, any system will have two parts, which is the internal energy and kinetic energy. For non-relativistic kinetic energy, it will equal half mass velocity square, and the momentum of the particle which has moment p and energy, the momentum p will equal mass multiplied by the velocity. So the velocity will equal momentum divided, this velocity will equal momentum divided by the mass. Momentum divided by the mass, and another thing, the momentum itself, it will equal h prime, which is Planck constant, multiplied by 2 pi multiplied by k, and k in this equation, we are meaning the square root of 2 multiplied by mass multiplied by the energy divided by h prime square. So the square root of 2me divided by h prime square. So this is the energy of the particle, free particle, which has zero potential energy. Then from these points or these topics, then what is the wave function is, or what is the plane of wave function is, or what is the plane wave. Plane wave is the term which is named for the wave generated by the free motion electron, which has momentum p and it has its own energy E. So we can describe the free particle with those two quantities like momentum and energy, because it can be simulated through the sinusoidal varying. So this is plane wave. It's the wave function in this equation, but we are assuming b equal to 0. So b equal to 0. So this is a sine k of x, and a is the amplitude of this function. But the last thing we would like to mention in this here, sinusoidal wave is plane wave. It's produced for free particle which has momentum p and energy E and its amplitude a. But if we know precisely the momentum p, suppose that you know precisely the momentum p for this free electron or this free particle, we still, even we know this momentum energy, we still cannot determine where is the position of this electron or this particle, because the very large value of uncertainty for the position of this particle. As you can see here, this is the wave function. This is a wave function. It's a plane wave, but it's wave function. So this is the wave. It's varying over x-axis. Electron or the particle could be anywhere over these long lines. So there is large uncertainty. It could be anywhere here, even anywhere here. So we cannot precisely determine where is the particle is due to the wave nature of this particle, duality nature of this particle. This is why we cannot determine precisely where is the particle and what is the momentum, even if we precisely determine the momentum of this particle.